Hi everyone, my name is Lin. I'm gonna do the question 7 of homework 7, so let's begin. So for the subproblem A, it tells to find the expectation of ZT, and we know that NET and N2T are both WSS, so we know based on the properties of the WSS, we know the expectation of the NET actually equals to E1, which is a constant, and the expectation of N2T also equals to a constant, which we set to eta2. Then we can calculate expectation of ZT. We just substitute the ZT into it. It equals to NET times cosine thing and plus N2T times sine thing. And we can just separate into two parts. The first part is the NET times the cosine thing, the expectation of it, and plus the expectation of N2T times the sine thing. And we know that NET, N2T, and theta are all independent from the problem. So here we can just also separate it by times. So we know it equals to the E NET times the E cosine thing plus, and we can also separate the second part of it. So it plus to the E N2T times E sine thing. And then we know the E NET actually equals to the eta1, and the cosine omega ct plus theta, the expectation of it equals to the integral from 0 to pi cosine the thing, and we know the theta is a uniformly distribution from 0 to 2 pi, so it's 1 over 2 pi at d theta, and plus the second part is also similarly is equals to the eta2 times the integral from 0 to 2 pi sine this thing, and also 1 over 2 pi d theta. And actually this integral from 0 to 2 pi is actually equals to 0, and also this integral from 0 to 2 pi is also equal to 0, so the result will be equal to 0 plus 0, so the final result is actually 0. Okay, that's for the subproblem A. And for the subproblem B, it tells to find the RZT2 and tells to find its ZT-WSS. So we first calculate the RZT2. It based on the definition, equals to the expectation of ZTE times ZT2. And we can just substitute the ZT and the ZT2 into it. The ZT is actually equals to this thing, and the ZT2 actually equals to this part, and this time between them. And then we can just expand it by multiply the first part to the first part to the second part, and the second part to the first part, the second part of this part. So we will get 4 terms. And the first term is the T cosine this thing times NE T2 cosine this thing, and plus the second term is a T1 cosine thing, and times N2 T2 sine this thing, and third term is this like this, it's N2 T1, and here is N1 T2, and last part is N2 T1, and here is N2 T2. So, and we also have NET, N2T, and theta are dependent. So here we can, like for every term, we can just separate it. So the expectation of this thing is actually equals to the expectation of NET1, NET2 times the expectation of this cosine thing inside, and similarly for the second part, and also for the third and the fourth part. And here we know that ENET1 and ET2 is actually equals to the RNE tau, and here tau equals to T1 minus T2 because we know NET1 and NET2 are. We know NET is actually WSS, so it's the property of WSS. And here inside this expectation, this cosine thing, and also we do have sine cosine thing, sine thing, cosine sine thing. Here we will use this what is called product to sum identities, so that we can actually transfer this multiply thing into a plus thing. So we know that actually cosine it will be equal to 1 over 2 times this cosine, the sum of this cosine thing, and plus the cosine here is the actually omega ct1 plus theta minus omega ct2 plus theta, and it will eliminate the theta, so the second term will be cosine omega c tau, and here tau also equals to t1 minus t2. And also it's similarly for the second part, third part, and the fourth part. We can just use this product to some identities to have this result. So for the second part, it's equals to the sine thing minus this sine thing. And for the third part is actually sine thing and plus sine this, and for the third part is minus cosine the sum and plus this cosine sum thing. So then we can just calculate each part by the expectations definition is called integral, and here we have the integral for every part of it, and then we can and we know from the subproblem A, we know that all of this integral from 0 to pi will actually equals 0. So all the things left will be this second part of it. Like for the first term, all the things left will be this cosine omega theta, and also here we will have minus sine omega theta left. And for the third part, it will be sine omega theta, and for the fourth part, it will be minus cosine omega theta. And then we have this result. And now we know that the second term and the third term can be eliminated because they're the same. So the final result will be 1 over 2 times the Rn1 tau plus Rn2 tau times this cosine omega c tau. And it will actually equals to the Rz omega tau, because what is only remaining is actually the tau. So we know that therefore z tau is the WSS. And for the subproblem A, it tells to find the RZ0. So what we can do is actually substitute 0 into it. So it actually, based on the result of the subproblem B, we know it equals to 1 over 2 Rn10 plus Rn20 times cosine 0. So here, which means tau is actually 0. So we can just calculate it. It actually equals to 1 over 2, and Rn10 actually equals to En1 tau plus 0 times N1t, and Rn2 will Rn2 0 will be equal to the expectation of N2 t plus 0 times N2t, and the final result will be like 1 over 2 times the expectation of N1t squared plus the expectation of N2t squared. So that's all for the problem 7. Thank you.